You are welcome to my class today. In this class, we are going to learn the types of average molecular speed of gas molecules. When we place gas molecules in a container, they move randomly and therefore, due to their motion, they possess speed. But there are different types of average molecular speed that can be possessed by gas molecules that are moving in a container. The first one is what we call the most probable speed. Okay, I will represent it with CP. Number two is arithmetic speed. Arithmetic speed, I'll represent it with C bar. And number three, we have the root mean square speed of the gas molecule. I'll represent it as root of square speed, the root of the square speed. So we have the most probable speed, CP, arithmetic mean speed, okay, C bar. Now, what are the formulas to calculate these speeds? CP will be equals to square root of 3kt over m. K is the Boltzmann's constant, T is the absolute temperature, while m is the mass of a molecule. So this becomes equals to, since we know that K is equals to R over Na, okay, the molar gas constant per Avogadro's number will give us what? K. That means that this becomes equals to square root of 3, instead of K we put R, okay, T, then all over the Avogadro's number multiplied by the mass. Now we know that Avogadro's number multiplied by mass will give us the molar mass. So that will give us square root of 3RT divided by what? By the molar mass. So this formula is the formula for what? The most probable speed of gas molecule. Then arithmetic mean speed of gas molecule will be equals to square root of 8kt over pi m. Pi is 22 over 7. Now if you replace k with R divided by Avogadro's number, we'll be having square root of 8RT divided by pi m. So this formula will be the formula for the arithmetic mean speed. It is also equals to 1 over n summation of n equals to I to n, then C what? Ci. What it simply means that this will be equals to what? N1 C1 plus N2 C2 and so on, divided by N1 plus what? N2 and so on. So this equation will give us the formula for the arithmetic mean speed. Then for the root mean square speed, let us take the formula of that root mean square speed. The root of the mean square speed is equals to square root of 3kt divided by m. This will be equals to square root of 3RT divided by molar mass. M is molar mass. And this is also equals to 1 over n summation of I to 1n C I square. That will be equals to n1 c1 square plus n2 okay, c2 square plus n3 c3 square, everything over n1 plus n2 plus what, n3, and so on, depending on the number of molecules. So I've given you the three types of molecular speed, average molecular speed. I've also given you their formulas. Now let us take one question on this. Now we have to take a question. Find the most probable speed, comma, the arithmetic speed, and the root mean square speed of hydrogen molecule at a temperature of 0 degrees Celsius. We want to find these speeds at a temperature of 0 degrees Celsius. Now, we are talking about hydrogen. The molar mass of hydrogen is 2.016 gram per mole. Then the temperature, absolute temperature, 0 degrees Celsius is 273, okay, Kelvin. Now, the most probable speed will be equals to square root of 2RT divided by the molar mass. So that will be equals to 2 multiplied by the R is 8.314, okay, Newton meter. Newton meter is the same as joule. So we're having Newton meter per mole, okay, per Kelvin. Then multiply by the what? The temperature, which is 300 what? Kelvin. So this Kelvin here can cancel this Kelvin here. So we have divided by the molar mass, which is what? Which is 2.016 gram per mole. We are taking the square root. So when we multiply this out, we'll be having that our CP will be equals to, okay, let's check our calculator, 47.452. That is 47.452. Okay, 47.452. So we are having n1 over 2, okay, n1 over 2, then m 1 over 2, then g minus 1 over 2. Remember, the per mole here, we cancel per mole here also. So when you do 2 times 8.314 multiplied by 300 divided by this, you will have what? That when you take the square root, you have this as an answer. But remember, this n is under square root, so it's 1 over 2 to represent the square root. Then also we have m, the mass, 1 over 2 for the square. Then g, okay, when g comes up, it become minus g. Then, but because of the square root, we have this. Now, since we are looking for what? For speed, we are not going to what? We are not going to be taking this n raised to power 2, m raised to power 2 as what? As our unit. But what we must understand is that what? That 1 Newton is equals to kilogram meters per second square. okay, which is the same thing as kilogram is 1000. You have 1000 gram, that is 1 kilogram. Then meter per second what? Square. If that is the case, okay, it simply means that what? N raised to power 1 over 2. I don't know if you are seeing from here, okay? All right. N raised to power 1 over 2 will simply become equals to 1000, okay? N raised to power 1 over 2 will become, okay, 1000 G ms minus 2 all raised power what? 1 over 2. That will give us the root of 1000 is 30. If you take the root of 1000, we have 31.623. 31.623. Okay? This will be raised to power 1 over 2. Also, the m will be raised to power 1 over 2. And the s will be raised to power 1 over 2, which will give us s minus 1. Alright? Are we getting it? Alright. So if that is the case now, you can now see that our CP now, if we replace this n over 2, okay, with this, what do we have? We will see that our CP now, CP will become equals to, remember, we have 47.452. Instead of n 1 over 2, we put this. So we multiply by 31.623, okay, gram 1 over 2, okay, then m 1 over 2, then s minus 1, okay, that is for this. Then we'll continue our journey from m 1 over 2 g minus 1 over 2. So if you simplify this, your CP will automatically be in meters per second. So from this thing I have 1500 meters per second. So that is to say, when you are using the formula, you have to multiply by 31.625 in order to convert the total unit of what? Of speed to be in meters per second. That is to say, we have gotten our answer for CP. Then our C bar, which is what? The arithmetic mean speed by formula, is equals to square root of 8RT divided by pi what? M. I mean pi M, that is the molar mass. So this will be equals to square root of 8 multiplied by 3.1, okay, 8.314, 8.314, then multiply by temperature, which is 300, divided by pi is 3 point, that is 22 over 7, 22 over 7, multiplied by molar mass of oxygen, 2.016. Then, for us to convert our units using this equation to be in meters per second, like we did the other time, we'll multiply by what? By 1.623. So when you do that, our answer will be automatically in meters per second. Now, what is the answer? Using calculator, we have a C bar to be 16.94 meters per second as what? As the answer. Then the last is a C bar square, which is what? The root mean square speed. The root mean square speed is square root of 3RT all over m. Okay, which if we want to make it to become in meters per second, we simply multiply by what? 31623. This is the conversion factor. So this will give us square root of 3 times 8.314 multiplied by 300. Okay, then divided by the molar mass, which is 2.016 multiplied by 31.623. So when we take that, here I'm getting 1838. So that answer, which is c bar square, will be 18, okay, 38, okay, meters per second. So that is the answer for the three speeds: most probable speed, arithmetic mean speed, okay, and the root mean square speed. I will take another question on this. Calculate the arithmetic mean speed and the root mean square speed of the following molecules, or the following molecules. Okay, we are having 10 molecules moving with, okay, 5 times 10 raised to the power 4 centimeter per second, comma. Then we have 20 molecules moving with, okay, 10 times 10 raised to the power 4 centimeter per second, and 5 molecules moving with 15 times 4 times 10 raised to the power 4 centimeter per second. So that is it. We want to calculate the arithmetic mean speed and the root mean square speed of the following molecules. 10 molecules moving with a speed of 5 times 10 raised to the power 4 centimeter per second, 20 molecules moving with speed of 10 times 10 raised to the power 4 centimeter per second, and 5 molecules moving with speed of 15 times 10 raised to the power 4 centimeter per second. Now, to apply this, we know that our C bar is equals to N1 C1 plus N2 C2 plus N3 C3 divided by N1 plus N2 plus N3. Okay, that means that C bar will become, the first number of molecule we have is 10 multiplied by the speed. What is the speed? The speed is 5 times 10, 4. Okay, then plus the next molecule is 20 times the speed. The speed is 10 times 10 raised to the power 4 plus the next molecule is 5 multiplied by the speed, and the speed is 15 times 10 raised to the power 4. Okay, every one of them divided by, okay, 10 plus 20 plus what? Plus 5. If we do the calculation, my C bar mathematically using calculator is 8.28 centimeter per second. That is the answer. Okay, then we can equally get the root mean square speed of these molecules. All right, I can wipe this one. The root mean square speed, root of the square speed, is given to be n1 c1 square plus n2 c2 square plus n3 c3 square over n1 plus n2 plus n3. I think that will be, okay, 10 times, the speed is 5 times 10 raised to the power 4, but you need to square it, plus you have the next, which is 20 times the speed square. The speed is 10 times 10 raised to the power 4, all square. Then plus the next, which is 5, multiplied by the square of the speed, which is 15 times 10 raised to the power 4, all square. Then everything divided by 10 plus 20 plus 5. So that means that c bar square will be equals to, if you do the mathematics, I'm having 9.82, okay, times 10 raised to the power 4, all right, centimeter per second. So the first answer I got, the first answer is 8.28 times 10 raised to the power 4 centimeter per second. That is C bar. Okay, that is the first one. Then our root of the C bar square is giving us 9.82 times 10 raised to the power 4 centimeter per second. So these are the two answers. So when we take that, thank you very much. I believe you have learned some tips on how to calculate the average molecular speed of gas molecules. I want you to subscribe to this channel, share the channel, okay, I mean the video, share it, okay? Then also you can like. This is very important for your examination. So follow up. You can put any questions in the comment section. Thank you very much.